All right, another session. This time we will talk a little bit about infrastructure as code, but not infrastructure as code itself, but if it is secure, and if not, what we can do to make it a little bit more secure, what is quite important, I believe. Okay, so let's get started. My name is Pawel Piwosz, and I am a lead system engineer at EPAM Poland. I work here for last 2.5 years, almost 3. Also, I am DevOps Institute ambassador and AWS community builder. So we will have a little presentation today. Part of it will be in AWS because, well, you see why. All right. So first of all, we will talk about security in Terraform templates. So what is Terraform? I strongly believe that all of you know it already, but just to be sure, it is an infrastructure as code tool, right? So very, very basic information, right? So what is infrastructure as code then, right? So infrastructure as code is a fast, dynamic, programmable way to deploy hidden misconfigurations everywhere. Yep. And when we start to think about infrastructure as code in this way, the new world opens. Because very often we use infrastructure as code just like this, right? We are writing something, deploy, rewriting, deploy, rewriting, deploy, rewriting, deploy, and after 2 days, finally our template is ready, right? I've been there. I know that is quite, let's say, not usual to see something like that, but we have possibilities to work with it a little better. So in terms of security, what we deal with. So for sure you remember like almost 2 years ago SolarWinds, right? To go a little bit through it, to give you a little bit more insight. What happened there? So the breach was done for the company which has like 300,000 customers, right? And 30,000 used Orion with the application which, let's say, were infected. This infected version was downloaded or were downloaded 80,000 times. 80,000. More than 10 government institutions in US was infected or affected by this this version, and to say even more, Microsoft, Nvidia, Palo Alto. What is interesting because they are also working with the security different level, but yes, and VMware, just to list a few of them. And Orion was the first, and like a half a year or 1 year later, they had another issue, right? So now you can say, all right, but it was not about infrastructure as code, right? Okay, I agree, but this is what we deal with, right? And this is one of the elements of the puzzle. So let's look on a few numbers first. And those numbers are collected from IBM and Ponemon Institute report from, well, almost 2 years right now. So it's for 2020. So average cost of each breach is almost 4 million. Quite a lot, right? All right, IBM and Ponemon works with big customers, or big organizations, but anyway, this will be interesting because average time to identify and contain the breach and the breach is 280 days. From which 207 days in average is to identify the problem, and then more than 70 to contain the problem, so to fix the problem. IBM and Ponemon identify the percent of breaches by different areas, and in cloud misconfigurations, we are almost in infrastructure as code. So breaches caused by cloud misconfiguration, for their report, it was 19%. So 1/5 of all breaches because of the cloud misconfiguration. It starts to be quite, scary, right? So what kind of cloud misconfigurations we had and breaches because of this? So in 2019, Imperva had a breach where they lost customer records like API keys, TLS certificates, etc., right? Because of network misconfiguration, hard-coded API keys, and not encrypted records in database. Imperva identified the issue after 10 months. Another example of misconfigurations, Capital One, also the same year. More than 100 million records exposed, like bank accounts, social numbers of their customers, etc. Why it happened? Because there were misconfiguration in IAM policies and unencrypted storages. Those reports are obviously available in the internet, so you can search for them. There is a lot more, right, of them, but to give you the impression what we have. So what kind of cloud misconfiguration we can have? Really, two types. One is cloud misconfiguration itself, when we are creating some resources or we are updating resources, etc. And the second, very important and very tricky, really, is configuration drift. So I will talk a little bit about drifts in some time, but right now we need to know that drifts are definitely more danger because they are not monitored. All right. Okay. So what is drift? In fact, so drift is, as I said, is unmonitored, undocumented, change in the configuration done manually. In most of the times, right? Most of the cases. Because if we are talking about change done by infrastructure as code template or CDK or whatever, it is monitored, documented somehow, right? But this change is done manually by someone. No one knows when, where, why, right? And the very sad fact, 90% of organizations allow users to make changes without proper process. And as a proper process, I mean even go that high that you disallow or prohibit, let's use more, strong word, they prohibit access to business accounts for users. Okay, I mean access to console to play with resources on the account. And this is according to the DevSecOps state of DevSecOps by Accurix formally, because they are acquired by Tenable. It's also for 2020. So this fact is very sad and very unbelievable, right? So we are talking here also about financial companies, about healthcare companies, where the information is should be very secure. So if you are scared enough, we didn't finish yet. So now we are going to the new report from this year, and it is interesting because Sonatype did a report where they talk with 300 professionals, and they have very interesting information there. So 36% of professionals suffered a serious breach because of cloud misconfiguration. So of course, here we are talking about different group of people. That's obvious. So that's why we have different numbers. But I hoped it will be lower, but it's not, right? Very interesting is that almost 50% of teams had more than 50 misconfigurations per day. 50 misconfiguration, more than 50 misconfiguration per day. I say, wow, right? It's hard to imagine, really. So what kind of misconfigurations they find? So the most important, the most popular ones is misconfiguration of IAM. In all clouds, IAM are the core of everything. It's not quite, very clear, very well understandable for people how to work with them. But the main goal which we should look forward and try to achieve is to have as less permissions as possible, as required even, and go with policies like a one-to-one. So one resource has access to one other resource. And if this resource needs access to similar resource but another one, it means another policy, right? So we are decoupling the policies here. Yes, in the end of the day, we will have a lot of policies. There will be a total mess, total chaos. But first of all, we are working with them through Infra-as-code, right? And we have proper naming and proper tagging. This is also important. And the second obvious biggest percent is security groups. It's very tempting, very easy, and very common that, all right, I need to test something, I will just add my IP to SSH. Well, I don't know what is my IP, I will just put 0000/0. Done, right? So these elements are quite important. So now, how those teams, those people are catching the issues. And this is also interesting because 33% of them do manual checks before deployments. And by manual, I mean they are looking on the template. They have, for example, I don't know, code review or whatever. They are reading the templates and they can miss stuff, obviously. 27% of them do a post-deployment checks. What is really risky, right? Because this is already deployed. All right, so we know what kind of issues people have. We know how they catch and try to fix the issues. So how much time they spend on it. And this is also quite interesting. And I'd like to focus your attention here. So 4% of these 300 people said that they spend more than 500 hours per week fixing the issues, finding them and fixing. It means that 12 people from this 300 say that. So their teams spend 100% of time working with infrastructure as code security issues, and it's for 12 people. Work for 12 people. Only for this. It sounds scary, right? But we are lucky here, and we have helping hands. And with helping hands, I mean the processes, the approaches, like for example, shift left. What it means, this is like a paradigm, not only for software, which is obvious, right? Everyone is saying shift left in creation software, etc., etc. But it works also for infrastructure. We have, thanks to that, we have very fast feedbacks that something is wrong. Tools like SE, ST also can be relevant for infrastructure, right? So the static analysis tools. And again, like with the proper development, everyone is responsible for security, right? We can implement open policy agents or any software which are using this approach. And this is a project under CNCF, so quite mature and quite stable. I mean, stable from the perspective of big organization. It's not something what is like a ephemeral. It is here right now and tomorrow will be gone. No. This is like a policy engine that automates and unifies implementation of policies across the environments and allows us to enforce, monitor, and remediate policies across all environments and resources, right? And this is the one link which I want you to remember. All right. What we should do, we should control everything before we deploy. And here I'm saying that if you have infrastructure as code and you deploy it first on dev, then QA, then pre-prod, then RC, then prod, this dev environment, the first in the chain, is in the importance of this environment is exactly the same from the security perspective, like production. I know this like how it can sound, but let me ask you something. Would you like to create a bank account in the bank which has the exposure of dev and QA environments recently? Because I'm not. So if template is deployed, it is already too late. Let's put it in our heads, like daily Scrum. We also have daily Scrum, always have daily Scrum at 10 a.m. in our team. The same way, if we deploy template, it is already too late. All right. We should use dedicated tools to prevent deployments with misconfigured resources, and use CI/CD pipelines for it. Why this is important? Because CI/CD pipeline can have, first of all, implemented those tools, and then stop, fail, break the pipeline if something is wrong. Right? So we have a lot of tools around. To name a few, Chekhov, right? The only one which is written in Python here. Terraform, DevSec, two written in Golang. Another one, CFN-NAG. I think this is in Python as well, but I don't remember at this moment. So this CFN-NAG is especially for CloudFormation, right? And SNCC, for example. So here, all of them except CFN-NAG work with Terraform, with Kubernetes, with CloudFormation, except Terraform and DevSec, right? Obviously, because the name is even, part of the Terraform. All right. So also we have tools from Accurix, which are quite more advanced. Right now, they are acquired by Tenable. So I'd like to demo few of them, 3 of them really. It will be Terrascan by Accurix, Chekhov by Bridgecrew, and DevSec by Aqua at this moment, right? So this is the GitHub for Terrascan, for Chekhov, and for DevSec, and you can implement it in your own, pipelines. So let's see how they look like. I have very, very fresh installation of very, very fresh installation of a Vagrant machine because I don't need anything more here. So let's do first, let's install those tools. With Chekhov, it is quite easy, right? So what we need to do is pip install Chekhov. Probably I didn't have pip here. Oh, yes, exactly. First I need to get update. So we spent a few seconds here on this, or even more. Let's see. So as I said, Chekhov is only one tool which we will test here, which is it's interesting. All right. This is quite interesting at this moment, but do not worry. I have a backup in mind. Okay, let's try maybe to stop it and oh, all right. Yep. So I have an issue here, so no worries. Let's do with it differently. Right, here I have my AWS console. We will go to EC2. I will create an instance very quickly. Let's use AWS Linux for it. I need to use default setting. I don't need anything else. All right. Okay, this is all right. At this moment, for the security group, I will say this. I don't care at this moment. All right. Please do not do that. I try to do this. I'm doing this right now only for the presentation purposes. Okay, create a new pair. Okay, let's call it presentation, download. All right, it is downloaded. Okay, so my instance is now launching. Right, something wrong happened here with this Ubuntu, so we don't care about that. Let's try to connect. Okay. It was presentation PEM, right? And now what I need to have is the IP of this machine. And it should work. Please work for me. Yeah, perfect. Okay, so we are going to become the root, and we try to install Chekhov. Okay, pip is not found. All right, so what I need to do is to install pip. I don't remember right now how what it is here in Linux or in the Red Hat, so I know already. Okay. Oh, all right, got it. Default problem. Yeah. Of course, I should install it as a user, but here only for this presentation purpose. It's okay to have this. Okay, so now I should have Chekhov install. Let's try. Maybe I need to do this as simple like that. Looks like not. All right. Chekhov not found. So let me just check where it can be, because it should be installed really in our. All right, let's come back to this a little bit later. Right now we will install. How I did it? Okay, pip install checkoff. So should be here. Let me just repeat it. Just to, you know. And now let's try to do maybe the same thing here. Just to speed things up. Oh, yeah. I have it. Right, so checkoff is installed, right? So now what I want to do is to install Terraform. Okay? So this is the tarball which I need to install. First download, obviously, right? I have it. So now let's me unpack it. Okay, what happened here? Let's try maybe with the name. Okay, I have some issue here again. For some reason things do not want to work for me today. So let me try to do this again. All right, let's check. I have it. All right, I have it. So let me try to yeah, probably some typo or things like that. All right, let's remove the bundle. Okay, now what I need to do is to install Terraform into USR bin, USR local bin. Install, of course. All right, and now I can remove it from here. All right, so now let's try if I have it. Yes, version 2 dashes. Yep, without dashes, just version. Okay, version 1.12 is installed. All right, so now the last tool, DevSec. Let me copy it. Okay, I have this one. Yes, and as you can see right now, this one is downloaded not as a package, but just like a executable or almost executable. So let me first let me just move it to DevSec to have like more clear name. We need to do ch mode for it, and obviously we need to install it DevSec into bin USR local bin and remove it from here. Let's check. Yeah, we have it in version 0.66. 0.60. Okay, so what we will do now? Let me check if I have Git. I do not have it, so let me just install quickly Git. What I will do, I will clone a Curix test templates, and we will see how they work on it. Okay. Why this template? Because they prepared quite interesting and problematic templates. All right, so let's go to Terraform directory, and we are here. So how to execute checkoff? It's very simple. We need to put checkoff -d means directory, obviously, and let it be our current directory. Bam. We need to wait a second or two, and this is the effect. All right. So as you can see, a lot of failed or fails, and the organization is clear. You have all information here: what failed, what resource, what file in what lines, from where this file was called, what is the code here, and also the guide. Right. This guide means some information how you can fix it. And on the top, there's a lot of it, as you can see. Oh, come on. On the top, there is a summary. So summary which should be on the end. Let me do this differently. All right, so as you can see here, passed checked is 44, failed checks is 58, and nothing was skipped. Skipped means that you can say that specific checks need to be skipped. You don't want to check them. Because, for example, Chekhov has the scan, which is checking the description of your security group. Maybe it may be an issue for someone that this is not described properly. I mean about AWS, but it's for sure it's not the security issue, right? So here, for example, when I have my security group for this instance, let me show it to you. Here you see this description field. So generally we can say what is the reason of having this specific record, right? So this is Chekhov alerted as a problem. Okay, so this is Chekhov. Quite nice. Let's try with tfscan. I mean tfsec. So here the syntax is a little bit different. And you have even the information about the use of disk IOs, about what was the time for evaluation, runnings, etc., etc., how many files were checked, loaded, modules, and the results. So we found 10 criticals, 10 high, medium, low, and ignored. As you can see, there is a less. So tfscan found less issues, but it doesn't mean it is worse tool than Chekhov. Chekhov is finding different issues, right? There is like a common part of issues that all three tools are catching, but I did a quite extensive tests for all of them, and results said that I should have 3 of them in my pipeline to be like 90% sure what I'm doing, right? So quite not perfect situation. All right, so this was tf-sec. How to do with Terrascan? Right now we are saying something else. Terrascan scan, and we are scanning it. And Terrascan takes the most resources, takes the most time, so it's the longest run, even if it wasn't shown here. Maybe they improved something, but like 1 year ago, this time was definitely the longest because Terrascan had implemented API inside, so you were able to run Terrascan as like a separate tool which is available all the time, like SonarQube, and just execute the API call from the pipeline, which is very useful because you don't need or to prepare proper image for your pipeline or download the tool all the time. As you can see, we have 20 high, 13 medium, and 5 low. 38 policies are violated. So this is how they work in the most default options. All right. I don't want to show you definitely more complicated options for very simple reason, because I strongly believe that the beauty lies in simplicity. So if something works from default, out of the box, that is perfect tool for me. So this is how I run them just through my Linux machine. So how it looks in the, maybe first I will show you the template of pipeline which I created, because I've created my pipeline using CloudFormation. So this is the template. Very simple. I didn't pay too much attention on the roles, but I need to have few roles in order to have the security, my pipeline, AWS code pipeline. And I have 4 blocks inside. One is mandatory to pull source. I'm doing this using my own created repository in the code commit. And then I have my tests, where one block is for checkoff. Second is for here DevSec, and third is for Terrascan. And here the configuration means this, like a general approach to doing things, right? So I have my phases. During the install time, I'm installing checkoff, creating the directory for reports. Then during the build, I do the proper test. And as you can see here, I stream the output into the file. Why? You will see in the moment. The same situation. Of course, the installation process is different. Is for DevSec, and also I have the possibility to send output in JUnit format into the file, and the same for Terrascan. I'm streaming it to the Terrascan XML file. Right now, all 3 tools are allow us to use JUnit to have proper reporting. What is really perfect, because when we go to code build, and I mean more like a code pipeline, we have our pipeline here which is failed, and it is on purpose. So let me just release this pipeline again. Right now, this block, this mandatory block, will pull code. Come on, yes, it did it. So let me open all of those scanners here. As you can see, I'm executing them in the same time. In fact, it's not always the same time, but generally the idea is to have them in the same time. And then, of course, I can have another next steps. But for this presentation, this is what I need, really. So, as you can see, there is a lot. It's generally what happened, the same happened in normal execution, right? So, as you can see right now, this command was executed, and of course, it failed. And this is also very important. All 3 tools can fail your pipeline. So this is very good, let's say. So I told you that I sent this to this file, to this report, and also I published this report. So here we can see how the report from checkoff looks like in the code pipeline or code build. We see that 20 checks failed, 84 was positive. This is for different repository, not this from Accurix, another one. And we have the full information what failed, really. Okay, so this is checkoff. Let's see what we have for DevSec. Download, preparation, and then we have the execution. DevSec is only one tool which is much more happier if Terraform is installed. It can work without, but it's definitely more happier. So again, we have the reporting. Let's see what we have in the report. All right, 11 tests failed. We don't know how many passed, unfortunately. And again, we have the information here about everything. What about Terrascan? Again, download, installation, and as you can expect, it failed. Perfect. What we have in the report? Right, 14 checks failed, 16 passed. So, first of all, only DevSec doesn't show how many checks pass, right? It can be useful information. If you build metrics on it, on this report, it may be interesting. How many checks in time, how much more checks in time you have, and how many of them failed. So, I prefer this option here, not like this one. And this one is also perfect. And so as you can see, 20, 84, 11, 14, 16. So different policies, different checks, different findings. Which one will be best for you? It's up to you. It's really up to you. You should go with all of them, check them, look how they work, right? And then decide what to use. Right, so this was the presentation, but we didn't talk about one important element too much, about drifts, right? So what about drifts? The challenge here with drifts is that drifts have to be controlled continuously. And there is always someone who has elevated privileges, right? So even if I say that we should prohibit it, there is always the root who can do things, right? And we need to remember about that. And the available tools not always cover all possible changes. The best example here is the drift detection from CloudFormation, which catch a lot of stuff, but definitely not all of them, right? Even from the list of this, you remember this percentage, from this list, drift detection has problems. And important and very unpopular, management must understand that if they say to you it must be done now, it means a lot of risks, right? What tools we can use for drift detections? driftctl, acquired by Snyk recently. kubediff for Kubernetes, right? SaaS offerings like Bridgecrew, Accurix. They have offerings, paid offerings, of course, for continuous monitoring of your templates, of your misconfigurations, and your drifts. So we should go into new level, right? Just even beyond just scans. We should have everything as code, and it means that with those newest offerings, we are able to create automated control and remediation processes. And security must be implemented on the earliest possible stage for infrastructure, for everything, right? And everything as code means here policy as code, means security as code, means drift as code with those offerings, right? With those paid offerings, and remediation as code. And what I'd like you to have as a takeaway from this session is that please do not pretend that you have security, because every possible misconfiguration will be explored. now, tomorrow, in 1 week, but will be, right? For a few years ago, for a wrongly configured Elasticsearch, it was like a couple of minutes needed to have Elasticsearch hacked. Couple of minutes. And security is very complex and expensive. Thank you very much. I hope you enjoyed the session, and I hope you enjoy all sessions from this conference. Thank you.